Good afternoon, guys. Today we're going to be doing reviewing the polar coordinate system, and for me this is a review for the finals. It covers the polar axis, how to plot points in the polar coordinate system, and multiple representations of a point. So the polar coordinate system is different from what we've been seeing so far in our lives in math. What we've been used to seeing is the rectangular coordinate system, which the points in the rectangular system are represented by x and y, so x comma y. But instead, in the polar coordinate system, we use r and theta to represent a point in the system. And as you can see in here, the polar coordinate system is basically made up of concentric circles, so circles with the same center, which is at the pole, and I'll talk more about the vocab in the next slides. So here is the pole, which is O, and the polar axis is basically the positive x-axis in our coordinate or rectangular system, and the r is the directed distance from the pole. So basically, if we have a point here, for example, this point here would be 2, the r value would be 2 because it's 2 circles away from the pole. And the theta is the directed angle from the polar axis, and it's measured counterclockwise, and then the negative angles are measured clockwise. Theta is usually expressed in units of pi, so radians. So just a recap of the vocab that you need to know, the pole is the origin, basically what we call the origin, and you can think of it as the origin in the rectangular coordinate system. And polar axis is the positive x-axis in the rectangular system. It's used as a reference for theta, which is the directed angle. So you start measuring theta from the polar axis all the way to the point. And theta is the directed angle, which is measured, again, counterclockwise from the polar axis to segment OP, which is right here. And again, r is the directed distance from O to P, as shown in the diagram. And just a reminder that the polar coordinate system, a point is represented by r and theta, the directed distance and the directed angle. So right now, I'm going to use Desmos graphing calculator, which is an online free graphing calculator. It's really nice to represent points on the polar coordinate system using this graphing calculator. And in order to switch from this rectangular system, we go over to this wrench right here. It says graph settings, and we go to grid, and we go to this one, which is the polar coordinate system, and we are in radians. So now I've plotted the point in the polar coordinate system to pi/3. And remember that a point in the polar coordinate system is represented by r and theta. So this means that 2 would represent r, and remember r is the directed distance along this segment OP. And so this means that the point is here, right? So this distance, r, is equal to 2 because if you think about it, since the polar coordinate system is made up of concentric circles, a segment OP along here would basically be 2 circles away from the pole, and that's the length of r. And theta, which is pi/3, is the angle in radians measured counterclockwise from the polar axis. So this is how, and then the plotted point is right here at point P. Another point that I plotted in the polar coordinate system is 3 negative pi/6. So in order to plot points really in the polar coordinate system, you need to be familiar with the unit circle, since the polar coordinate system is made up of concentric circles. So 3 represents r, and we are 3 circles away from the 1, 2, 3 circles away from the pole, which is right here, and our theta is negative pi/6, which is the angle from the polar axis to this directed segment OP. And it's negative because it's not going counterclockwise. In this case, it's going clockwise, which is why it's negative. So unlike the rectangular coordinate system where each coordinate is its own unique point, a point in the polar coordinate system can be represented by multiple points. In fact, this point, 3, negative 3 pi over 4, can be represented by 3 other, they're the same point, but you use different values for the r and the theta. So to give you a clue of how the other 3 points can be represented, and this rule basically applies to every single point in the polar coordinate system. So since this 3, negative 3 pi over 4 is a positive negative, this means that the other points can be positive positive, negative negative, and finally negative positive. These are basically the possible representations. And for the positive point, remember this is our original point, 3, negative 3 pi over 4. This is our positive negative point. So the first easy point that we could find out, which could be a positive. So what is the positive directed angle of negative 3 pi over 4? Well, in order to know that, we have to look at our unit circle again. And negative 3 pi over 4, if we can find it, this is pi over 2, which is 2 pi over 4. This is negative 3 pi over 4 going from the polar axis. Negative 3 pi over 4 is represented by this line here. And another way you could write negative 3 pi over 4, well, you could go from the positive axis all counterclockwise now instead of going clockwise, and going back to this point all the way from the polar axis all the way to this line is 5 pi over 4, because this is a whole 4 pi over 4 and this is another pi over 4. So our additional point would be 5 pi over 4. And the negative, well, let's see. For a negative, it just means that for example, 3, negative 3 pi over 4. If it were negative 3 pi over 4, that means it would go on, let's assume that there's a line here, it would be on the opposite side of this line, and this point would be the same distance from the pole as the negative 3 pi over 4. It's going in the opposite direction of this angle. So what is the angle that is opposite from negative 3 pi over 4? We are, the angle opposite from negative 3 pi over 4, well, if you go along this line, this would be pi over 4. So our angle is, actually, you know what? It would be easier to start with the negative positive. So our angle would be pi over 4. And what would be the unit? Well, it would still be 3, except now it's negative 3 for r, because if we go from pi over 4, let's assume that this is the third circle from the pole, and we go opposite. Negative means that we're going opposite from the pi over 4 along this line, and this will be negative 3 pi over 4. Now let's go back to the negative. So the negative, you are basically just taking the negative angle of pi over 4. So we still have our negative 3 as our r, because we still have to go in the opposite direction of this negative of pi over 4, but instead we're going to do the coterminal angle of pi over 4 in the negative direction, so clockwise. So clockwise all the way to pi over 4 would be negative 7 pi over 4, since this is a 4 pi over 4, this is 2 pi over 4, and this is 1 pi over 4, or pi over 4. except it's negative because it's in the clockwise direction, and it's negative 7 pi over 4. And these are all our representations of our original point, 3, negative 3 pi over 4. This is a kind of like a formula you would use, I guess, to find all the points that represent r and theta. But I think it's much easier to use this example that I had below, just to use your logic and knowledge of the unit circle to find the other point. As you can see here, it looks kind of confusing. And as always, thank you so much for listening, and I'm sorry if I don't think my explanation was as clear as it should have been, but I hope this helped. And I will be releasing a video on coordinate conversions from polar to rectangular and converting polar equations to rectangular equations soon, so be sure to stay tuned for that.